Hello guys, welcome back. So here we have another simple question on network theory from GATE 2017. So in the circuit shown, the positive angular frequency omega in radians per second at which the magnitude of phase difference between the voltages V1 and V2 equals pi by 4 radians is dash. So here if you see the circuit, the voltage source is 100 cos omega t and V2 is the voltage between this 1 ohm and 1 Henry circuit equivalent, and V1 is the voltage across this 1 ohm resistor. Okay, so we want to find omega such that the phase difference between V2 and V1 is pi by 4. So V2 will be something like modulus of V2 cos omega t plus phi 1, and V1 will be some magnitude of V1 cos omega t plus phi 2, right? So if we go to the Fourier domain, so your voltage source, let's say the reference is 100, sorry, cos omega t, so this will become 100 cos 0. So I'll write cos omega t as a reference. So then we have 1 ohm, 1 Henry will become j omega into 1, so j omega ohm, and then we have 1 ohm again here. So now what does V1 become? So V1 of j omega becomes some V1 e power j phi 2, right? Similarly, your V2 becomes modulus of V2 e power j phi 1. So we want to find phi 1 minus phi 2 or phi 2 minus phi 1, the modulus. The modulus is given and we want to find omega such that the phase difference is pi by 4. So how will I get phi 1 and phi 2 from here? If I divide V2 of j omega by V1 of j omega, then my exponential it will add or subtract, right? So that is how I need to get. So now if we see V2 and V1 are unrelated. So if you want to relate them to the circuit parameters, what we have to do? Let us assume that the current flowing through is I of j omega. Then what does V2 become? V2 of j omega becomes I of j omega into 1 plus j omega. This is the impedance, right? Similarly, V1 of j omega becomes I of j omega. Why? Because still the same current is flowing here. Nothing is flowing through this because it is an open circuit. So this is I of j omega into 1 ohm, right? So now you take these both. What will you get? Let's say V2 of j omega by V1 of j omega. So from here what you get? Mod V2 by mod V1 e power j phi 1 minus phi 2, right? And here what do you get? You get I of j omega goes away. You get 1 plus j omega by 1. So this is nothing but 1 plus j omega. So if you see the left hand side is in r e power j theta form. Right hand side is like x plus jy. So let us convert the right hand side also to r e power j theta form. So 1 plus j omega, how can you write? Your r will be equal to root of 1 square plus omega square. So here anyway we are not bothered about the r. So I'll get 1 plus omega square. And what will be theta? Theta is tan inverse of y by x. So omega by 1. So this is tan inverse of omega. So this is e power j tan inverse of omega. So let us write this down. So V2 by mod V1 e power j. This is given as pi by 4, right? So pi by 4 is equal to root of 1 plus omega square e power j tan inverse of omega. So tan inverse of omega is equal to pi by 4 here when you compare these both. So tan inverse of omega is equal to pi by 4. So what is omega here? So it is tan pi by 4. And what is tan pi by 4? It is 1. So omega is 1 radian per second. So this mathematically we arrived at it. So intuitively, without solving all this, if you have to do, you have to just remember some mathematical things. So for example, here when you take this circuit, okay, let me put it here. So now they are telling V2 and V1, the phase difference is pi by 4, right? So V1 if you see and V2 if you see, the current flowing through them is same. This we already used there. So when current is same, the phase difference will purely depend on your impedance, right? So for 1 ohm, the impedance is going to be 0 degree. And this is like 1 plus j omega. And this one, if it is 0, for phase difference of pi by 4, what should be the phase difference here? Here the entire pi by 4 should come, right? So if pi by 4 should come for 1 plus j omega, your x and y should be equal. Then only you will get 45 degree, right? So your omega should be equal to 1. So this is how quickly you can arrive at without going through this entire derivation, where you also found the magnitude part which is not required. So the answer is 1.